Welcome to our PAM Northern Chapter CPD webinar this morning. I'm Architect B. Suyeng. You can call my surname B. You should notice there is a sign-in code. Please jot it down, and at the end of the seminar, we will show the sign-out code as well. And you need to fill out the Google form for the CPD purpose. For your information, this webinar will also broadcast in our PAM Northern Chapter Facebook page. You can share with your friends. However, those watch from Facebook were not able to claim the CPD point. A friendly reminder to all participants, please keep your mic muted to avoid interrupt to the webinar. Before the webinar starts, I wish to thank for NS BlueScope, Malaysia, Sdn Bhd, and United Citizens Sdn Bhd to sponsor this webinar and presenting the topic of adapting to the challenging impact of climate change. Our speaker will share on a series of critical design criteria that helps ensure the negative impact of climate change are guarded off. Today's webinar will cover a few interesting topics, which including our hot topic for all architects, which is thermal transmittance requirement or U value of roof insulation for UBBL 38A compliance, guide for SRI value, including the selection of color and material during the design stage to achieve the point based on Green Building Index criteria. Further, the speaker will also share about wind loading performance under MS 1553 2002, and also sustenance of water runoff during heavy rain through roof profile selection and roof pitch determination. This session will be presented by Encik Zaidi and Mr. Rocky Shet from Unisons and BlueScope. Encik Zaidi is a seasoned professional in the field of lightweight steel solution with more than 20 years of solid experience covering the manufacture of steel product development and design of roofing system, technical consultation, project management, and on-site support of countless icons both locally and internationally. Some of his notable projects include KTM Station, University Malaysia Pahang, Stadium Jengka, airports including Mars Aircraft Hangar, Phnom Penh International Airport, Siem Reap International Airport, and many more. Encik Zaidi vast exposure in the metal roofing industry has allowed him to understand various types of metal roof profile, the performance criteria, and possible customization to meet different design and technical requirements of different building types across various segments. Encik Zaidi is also a frequent speaker to local professional bodies include PAM, IEM, RISM, JKR, besides giving project consultation to private design build firm and developer in Malaysia. Our next speaker, Mr. Rocky, graduated with a bachelor degree in mechanical engineering from Monash University, Malaysia. Mr. Rocky experience include providing consultation on material selection based on different design intent and assisting building designer to achieve green building status, steel product research and development. To uplift the standard of building material in Malaysia, he is also involved in the development of Malaysia standard for coated steel and corrugated steel shade, such as MS 1196, MS 2383, and MX 2005. Mr. Rocky also a frequent speaker to a local professional body include PAM, IEM, RISM, and JKR. Okay, we will having a Q&A session after the presentation where you may raise your hand and unmute yourself to raise up your question to our speaker, or if you have any question throughout the seminar, you can type your question into the chat box for discussion during the Q&A session. So next, let us welcome our PAM Northern Chapter Chairman, Architect Leow Kun Chun, to deliver his opening remarks before the presentation starts. Over to you, our Chairman.
Yeah, okay, very good morning to all. On behalf of PAM Northern Chapter, I'd like to thank everybody who's attending. I'd like to thank Architect Casey Chong for organizing the seminar. Thank you, Blue Scope and Unison Kawa, for presenting the talk. Thank you to Mr. Zaidi and Rocky Shet. And thank you, Gary Paxo, for hosting the event. And thank you, Architect B, for being the moderator. And not forgetting, thank you, Pam Secretariat, for organizing the event as well. Please allow me to have some soundbite about climate change. I'm not a scientist, I'm an architect, but there have been a series of weather patterns like storms and flooding and fire in Australia recently. Expert has indicated these phenomena are unusual and it's possibly due to climate change impacted by human action. Impact of climate change to Penang in particular, there has been a simulation done on the rise of sea level due to climate change and its impact on Penang Island and Butterworth. Most of the coastal area near the island and Butterworth will be flooded because of the rising sea level. What can we do as architects? We architects should play an important role in contributing to reducing the impact of our design on the environment and climate change. What can we do in the process? We can actually contribute by choosing the right material that do not put a strain on our planet resources. We can design buildings that positively reduce the consumption of energy, water, and other negative impact on the environment. We can also take care in providing green spaces in our design to reduce the heat impact on our environment. Green spaces are good for physical and mental health. We in PAM Northern Chapter are constantly working with our members and other relevant agencies like MPPP, the planning authorities, and manufacturers like Blue Scope, Unison Kawa, in our quest to achieve carbon neutral development in buildings that will benefit our environment. And we continue to strive for that. I don't want to take up too much time. Back to you, Architect B, and back to the presenter. Thank you very much. Enjoy your session.
Thanks, Chairman. So next, okay, to proceed with your presentation.
Thank you, ARB. Well said, Mr. Chairman. It's a very good comment on the climate change. I think everybody now talking about a lot of climate change as is, I mentioned, is a man-made. I think I'm sharing the words that Chairman said now. I'm not a mad scientist or a weatherman talk about climate change so much so, but in our industry, we try to mitigate, or we try to do our best, as what Chairman said, to get a correct criteria of material design and what we can help the country, eventually the world, to fight this climate change. I think today I'm not going to be alone, as mentioned by ARB, that I'll be accompanied by Wingman today, Mr. Rocky Shet from Blue Scope Steel. Rocky, welcome.
Hi, morning.
Speaker.
Yeah.
We will share a few of my expertise and also what we are doing and what will be able to actually help by Blue Scope in achieving what we are doing right now, and to help the architects in a better way to design and adapting to the challenge of the climate change that we have right now. Right. All right, quick one. I will share my part of the company that I'm with. Actually, United Season actually is among the, not new, but we are not that long. So we have been 30 years in the industry, I think, and I'm proud to say that the pioneers of the founders of the company have been doing roofing since 1925. They have a lot of experience, and some of our experience are been I would say exported or been used in overseas, and we are proud of it. One of the company that able to expand ourselves in overseas. And Rocky, please comment about Blue Scope. In this case, you are my partner. We are being 100% Blue Scope user since many years ago. So we have only one supplier, and we don't call it supplier, we call it partners. I think, Rocky, to you.
Yeah. So of course, I think without getting too in detail about what BlueScope produce, I think everyone here knows that we produce. I mean, main business revolve around steel, which is one of the main components of building material. I think from our side, the legacy has been over, I would say a century. So from there, it proves that we have a long history in terms of good product as well as a reputable brands. So this gives you an assurance in terms of knowing that the material of the product itself can withstand the changing climate, and we have of course done our part in terms of looking into all these different aspects of just a minor component, but it is a crucial one nonetheless. And of course today we'll bring you through some of the critical topics to share with you what we think of this changing climate and how you can actually focus into the details to make sure that your building can withstand such changing climate. So today there'll be four main scopes that we'll be talking about. Of course, the main, the biggest one is I think facts and figures to tell you and to show So climate change definition, what do we see as climate change, and also reasons for the climate change happening, and also facts and figure and what we can do about it, right? So of course, Zaidi, have you seen, I mean, what kind of scenario have you seen, that is considered a climate change?
I think climate change have affected our life so much so lately. I think loss of life, loss of properties, that kind of things. I think it is now is something that we have to face even now and in the future to be seen. I think if you look at what's happening right now, Rocky, I mean the ice is melting, the gases actually produced by the human is actually getting worse and worse. We are losing our ozone as much as fast as possible right now. Then it's a as you said, the global phenomena, but created by predominant by burning fossil fuel. This is actually what we have right now. So on your side, it's been hot in your house, right? I guess nowadays. I think mentioned a few days ago when I checked in the net, one of the in India, the temperature right now is at 47 degrees on a day. I think we are already complaining about 36, 38 over here in Malaysia. Imagine if we are at 47. I think we're gonna have a lot of issues. Okay.
Yeah.
So. Okay.
Yeah. So in my perspective, I think when you say emissions of gas, definitely it affects how our material perform in terms of longevity and all that. Of course, when it comes to ice cap, the pole in Antarctic and all the ice in melting, it sort of gives more how to say water.
Yeah.
And of course, we do see it in Malaysia, where certain part of the country has experienced different intensity in terms of rainfall, which later on we'll be talking about and touch on how you can actually tackle it with roofing system. So yeah, Zaidi, back to you.
All right. So a quick fact, I think in 2020 the CO2 emission for Malaysia was 262 million tons. I think it's a big amount or big value for a small country like Malaysia. I think it's been increasing maximum up to 19.93%, and a bit of decrease is 0.95% in 2020 because you're talking about renewable power nowadays. And most of these, I think, came from cars that produce energy and also to produce our electricity. Yeah. Okay. So now, consequences of climate change. I think you look at these four photos. I think if you look at the bottom Right. I think that's happened in Northern. I think Penang is, they call it water head in column water in Yan Kedah. And even slightly in the north, tornado had never been seen in Malaysia, but it happened in Ipoh. I think on the top left, I think in 2021, we have a very big flood in Selangor. And we have a loss of life and a lot of property. And it create a lot of problem for people in Selangor particularly. Yeah. Now, what can we do? This is the run to adapting the challenging impact of climate change. Then what can we do? There's few things that we're going to talk about. We have a thermal, we have wind, we have water. I think this is three main elements that we want to talk about. So sounds, of course, is part of our when you have that thermal, obviously sound is part of a bonus that you can get. Okay, as when we design the thing. Quick one, yeah. So what's happening right now? I think the chairman has said that it's a man-made when it's the increasing of earth temperature. What happened in Malaysia, because the electricity, I always said when I was in overseas, the electricity in Malaysia was so cheap. What happened is you feel hot, everybody start to change their aircon to be bigger. When they change their aircon to be bigger, then they use more power. Then to create more power, then you start burning fossil fuel, you know, to create to have that energy, electricity in this case. So what we're trying to do now is actually how can we reduce this usage of aircon by controlling our temperature in our room or in our building as a whole. All right, some of you guys architects have seen this before. This is actually basically in our industry, roofing, the ability of metal roofing actually to adapt or even to have a custom performance that you can do easily. It's not like other type that you have a lot of restriction or something like that. If you look at these particular sections of simple metal roofing, you have a metal roof on top, and you have start having an insulation at the bottom. As you say, you have insulation wool, you have boards, you know, you have a lot of insulation material. I think, Rocky, quick one, I always ask this into most of engineers, what is the cheapest insulation in town? You know that? So insulation in town actually is air. By creating an air gap, actually you create something, but you must have a very big gap to get some of the U value that you want to do. In this case, to minimize the thing, there's a lot of insulation material. For example, as I said, insulation wool, mineral wool, and cement board, and people never thought of things like plywood or even gypsum board. We're able to give you the value that you need. At the end, we're going to talk about the U value afterwards on the next slide. So this is the system that you can create, customize, and actually achieve the thermal comfort that in a building that you're creating. I mean, for architects, we can help you on that one. I think quick one. I think thermal comfort is actually the ability to resist heat to coming into the building. So thermal transmittance of this U value can be calculated easily. When I said easily, actually you have it's just a simple mathematics things, but you get things right in terms of the value, especially the lambda, and also the K value, the R value. So basically, you put all the items, and then you can calculate it in the extrapolation kind of formula. Then you get the result. So I think this is a simple example that you have a metal roof on top, and you have an insulation wool, and you have a double-sided, and you have airspace. And in this case, we put a cement fiber board as part of the insulation. Then as a result, that the R value at 0.8. U value actually basically must be achieved having a thickness, not about so much so of other things. Thickness is very important in terms of catching the U value. So in this case, once you have the system, then you can come out with a result. An example of this system come out with at 0.32 watt per meter square value. So why that? I think this system has been I calculated by this slide. It is because under the UBB L38A, I mean, most architects have already known this, okay. So the roof U value, MS1525 clause 5.5, a new or renovated building, a lightweight roof, which is our roof, which is metal that is lightweight, consider, you have to achieve at 0.4 max U value. You cannot go higher than that, which is no good. I think U value is the lower they are, the better they are. In a heavyweight, I think it's a concrete roof or something like that, you have a 0.6. This is under Malaysian standard 38A 2012. Yeah. So of course, GBI play a very important role. I think architect has been in this information for GBI, how to achieve the U value, sustainable construction practice, everything. We are the one who will be able to help you to achieve it. Of course, metal roof is always on the building. Roof actually one of the biggest element in a building to some extent. We talk about high rise, but talking about a normal roof like house or factory or in a normal commercial building. Most of the time, roof are one of the biggest element actually in that particular design. Okay, kudos to Pulau Penang. I mean, Northern region, I know it's inclusive Perlis on Kedah, but I think everybody know it's been gazetted in 2016. I think, if I'm not wrong, among the earliest, even earlier than Selangor, to have this been gazetted as part of the rules and regulation. Under 38A, as I said, clause number 2, as mentioned just now, that is the performance that should be achieved to mitigate all these the so-called the thermal comfort for the building that in northern region. Hopefully other state will follow, but I think, as I said, kudos to Penang at this moment. So they're among the first to have this being gazetted as part of the law. Yeah, I think even it's a small law, but yeah, it's a law. Right. The other thing that under GBI also, there is, if I'm not wrong, I read it a bit here and there. I think they call it IC, internal comfort. So once you achieve the U value, you should be able to get this sound insulation, what's called it, performance. In our words, we call it STC, sound transmission class. I think should everybody know that. I think how does it works? How you resist sounds from coming into your room. That's where internal comfort coming in. So this simulation actually is shared by some of our insulation people. So in example, in the airport in Penang, I think Thailand was so small. Penang airport was so big, international airport. So if you imagine that you have a very building that very near to the airport and it didn't go sound. Right, actually, that's a sound that actually created by a jet blast from a jet taking off or passing by to your building, and if you have a poor insulation, what we call it no insulation, you could imagine that this on the left side, which is no insulation, right? The sound actually transmit or can enter into your room. That what will you hear on your room, but if you have a good insulation, I think we talk about 41 dB RW, yeah, I don't think anybody can hear it. I think 41 is good enough, yeah, right? So it's good enough to insulate yourself from sound. As I said, once you have the U value, you are able to achieve the STC 2-in-1. This is as I said, it's a bonus, or I mean some building required such good insulation on sound, like convention centers, that kind of thing. So this system works. I mean, while you are saving on your thermal, which is your aircon. I mean, convention center have used a big aircon. Then this will give you a lot of benefit for your building. So the next one is also sound absorption. Again, as I said, roof has been the biggest element in some building, as I said. So you can use sound, the roof as part of sound absorptions. I mean, part of ceiling is one thing, but for the example that speech, when you have a speech at
Doing so, he became the founder of modern acoustical
right.
engineering.
Okay.
He went on to design the acoustics of Boston Symphony.
Okay. So this is where you have an echo, I think, all over the hall or the room or something like that. But you can use the roof, again, as I said, part of the biggest element. If you perforated the steel deck, it will absorb the sound. I think you can try.
In doing so, he became the founder of modern acoustical engineering.
Right. It gave a more how do I say it, smooth sounds receivers inside the hall or the building itself. So again, either the sounds or the and the U value, they are very much related. And I said, I mean, in climate change, I think the U value are more important than to some extent on the sound. But of course, the sound absorption and the sounds class, transmitting class is a bonus to that building. Yeah. Now, Rocky, I have shown my part that I can do on my system on it, but there would be other element that could help that to have that energy efficient on the system itself. I'm not going to be alone here, but I believe that there are some other element that actually affected the way that the energy efficient that can be measured and also can be helped. Rocky, what do you think?
Well, you rightly touch on the energy efficiency of the roof system. So most often people do not really people look at whatever is physical, right? So in terms of U value, you can see the insulation, you can see the foil. Just now, Zaidi mentioned air gap, right? One of the cheapest and most efficient so-called insulator. So of course, when we are talking about insulation, so there is actually a first line of defense that most people take for granted. And this photo itself is a show of the temperature pickup from an urban area. So of course, when most people are now in an urban area, and increasingly people are again moving into the urban area. So what you have is an infrastructure that is very good at absorbing the heat from the sun. So it depends on how you use it. So of course, if you install a solar panel, then you can take advantage of the solar energy and translate that into electrical energy. If you have a water heater, then that translates into heating up your water, right? But most of the surfaces do not have that function. It's just there to either act as a first function of a structure, like roof or some other components like tarmac or roads, right? Which pave the road for our motor vehicles. But one thing that is most often overlooked is what we call solar reflectance index. And today, aside from choosing the right roof system or designing the right roof system, I'm here to advocate for solar reflectance index for the material on the material side. So solar reflectance index is the first line of defense when it comes to how much heat is being translated into heat, right, from solar radiation. So of course, typically, if let's say you look at colors, especially external components like roofing material, each color has different SRI value. And one thing that you normally would ask, I'm sure architects, some are very familiar, is you will always ask for a higher SRI value. And it is rightly requested and is relevant to how it can fight against climate change or increasing heat to the urban area. And it is also highlighted in the GBI guide book for different types of building. As what Zaidi mentioned, right? Roof is one of the biggest components in terms of building. Yeah. So if let's say your building is a low to mid-rise house or building, like a landed housing or rather commercial building, then it constitutes quite a big part of the roof of the external building, right? The envelope. So over here you can see that GPI has stated it as one of the component where you can actually score a point, provided that you reach a certain SRI value. So of course, if your roof pitch is 2 to 12 pitch, then your SRI value that you should achieve by minimum is 78. But this is a unitless number, unitless number, meaning there's no unit to it. So solar reflectance index is indicated in number without any unit. So of course, the higher the better, right? But what is the reason for it, and then why you should understand more? And today I'll share with you. And then how does it impact the overall building? Okay, so of course, before I go into detail, of course, without getting too science centric, but again, you need some basic understanding of it in order for you to take advantage of it. Is that when you expose the whole building envelope to sun, there are components of it that will translate into colors. That's why you see colors. So that is where the visible light is, right? The spectrum where you have a light wave within the wavelength of around, I think, 200 something to 700 nanometers. Beyond that, this is also where the sun will reach the crust of the earth. We call it a near infrared wavelength. Okay, so this part of the sun, solar energy, go through the ozone, right, and will shine. Will be reaching the crust of the earth. And this part you will not see in terms of color, but you are able to really feel it depending on how much of this part is being absorbed by the materials surrounding you. Okay, so let me share with a few examples. Okay, so say over here you have a roofing sheet or the whole building itself is painted with black color, right? Or certain components of your building is black color. Then there's this component of the color that is called solar reflectance. So this is not the whole solar reflectance index, it's just part of the component, right? It's called solar reflectance. So it's used to calculate solar reflectance index, but it's not the whole story. So solar reflectance is a measure of how the color react to this near infrared wave. Okay, so if let's say you have a really low solar reflectance, what happens is that the infrared ray that is shined onto this black surface, how much of it is being translated or absorbed to the material. So if you have a black surface, maybe most of it will be absorbed, counting by the number of arrows you see here. 3 arrows come in, but then only 1 leave. So it means that it has a very, very strong, very low solar reflectance because most of it is absorbed. Okay, so what if, let's say, I change the color of the roofing sheet material, or rather the whole building color to gray color? Then more of the solar ray and the near infrared spectrum will be reflected. When it's reflected, does not mean that it will go somewhere. Actually, it depends on the surrounding environment as well. So if let's say it is not absorbed, chances are it's being deflected back to the atmosphere and out to to our space. Okay, so it will not be absorbed. End of story. Okay. And if let's say you choose even a lighter color like white, then what happens is that most of the near infrared ray will be reflected back. Okay, so this is very important because this will affect how you choose color and how you actually convince your investor, or rather the design that you have, what kind of color you should choose. Okay, this is one of the informed decision, information that will lead to your informed decision. Okay, so of course, like I mentioned earlier, this solar reflectance is not the whole component of solar reflectance index, right? So there's another component to it, which is called thermal emittance. So thermal emittance works this way. So imagine how much of the heat energy is absorbed to one material. Okay. So thermal emittance is a measure of how much of it is, how readily it is to release this thermal energy or this heat back to the environment. Okay. So so it is actually surface dependent. Okay. Where if let's say you have a surface that is readily emit back to the environment, then most of the energy will be emitted back. But if let's say it is not, then it will actually absorb and translate it. It will not emit it in terms of the infrared way back to the environment. Okay, so what it means is that if let's say you look from a thermal camera, you can see actually how which component has a high emittance and which component has low emittance. So to show you one example, so you can look at your so-called oven, right, toaster or whatever. So what you can see from this short video is that despite the components within the toaster having the same temperature because of the heating element and all that, the environment itself is showing the same temperature. But then what happens is that different component like the glass that is shielding, that is enclosing the toaster, it has a different thermal emittance compared to the metal that is inside, right? So end of the day, this is a measure of, this is one of the components that will lead you to calculate the solar reflectance index. So we have to be aware that there are these two components, right? They are measured and also tested case-to-case basis, right? And from there, these two components will be calculated into an SI value, right? And of course, as you understood it, SI value, higher the better, right? So what it means over here is that if let's say you choose a material that has a higher SI value, especially, okay, we are talking about components that are exposed to sun, yeah? So this criteria would not be relevant if let's say you are choosing a component or architecture component that is not exposed to infrared or not exposed to sun. Okay, so rightly so is related to the roof and also whatever envelopes. Okay, so and of course you can also calculate it if let's say you search online, search for SI calculator. Then you can actually plug these two numbers in and to understand, okay, how does thermal emittance affect solar reflectance index, and how does solar reflectance affect solar reflectance index. So you can play around, right? There are a lot of calculators nowadays can be found online that is able to let you calculate all these values, right? But end of the day, different colors would give you different SI value, and different supplier or different paint system will give you different SI value as well, right? I'm taking my colors and my product as an example, right? So over here, what you can see is that there's a trend in terms of SI value, where the lighter color typically will have a higher SI value, right, compared to the darker color, right? But this is not the end of the story. Yeah. Later I'll share with you. There are certain ways that different producers would tweak their color to make sure that if let's say you want to achieve a darker color from for certain reason, then there are options out there that could still give you a different result. Yeah. So coming back to the story of this picture itself that I mentioned, that I showed you earlier. At the end of the day, choosing the color is very crucial, because when it comes to urban heat island effect, as I mentioned earlier, during the urbanization of the different population, there will be a lot of surfaces being created because of different buildings, right? So those materials are good at absorbing solar energy. So one thing is that you have more surfaces to absorb that solar energy and then retain it during the day, right? So these will heat up the overall environment. We are not talking about just one house here, because we are talking about the overall township, right? If let's say one part of the township is on average having a higher lower SI value surfaces, then the temperature of it is understandably will be higher in terms of air temperature, in terms of internal temperature and all that. And of course, it will have a knock-on effect to the energy usage and all that. That's what Zaidi mentioned at the start of his presentation, just now, is that if outer environment, the air space is heated up, then internally it will be heated up as well, right? Then you will turn on more higher power air conditioning, right? And that leads to more energy, because this is not a magical system, right? So when you cool down the space within the building, you are heating up more of the external environment, right? It's basically a zero-sum game. And what happens is that your environment will be heated up even more, okay? And this one will perpetually become worse and worse and worse, okay? So SRI value is one of the things that you should look into in terms of early design consideration. Of course, this is very easily switched. It depends on how you see the color, right? So today, with this information, I think it's good to use this information as one of decision making for you to design a greener township and all that. So of course, aside from determining the SRI value based on brochures, there are a few practical applications. There are a few practical considerations, in terms of choosing of material and all that. So of course, maintenance comes into play. The cleanliness of your building comes into play. So, so what I'm saying is that if, let's say, you have, say for example, a building envelope that is painted with the same color that has the same initial SRI value compared to the other one. But if, let's say, one of the building is not cleaned properly, or rather it's not maintained well, and then the surface darkens, or there are a lot of dirt and all that, then what you get is you get a dirtier surface, right? So this will have an effect this will definitely affect the SRI value. So if you look at the picture here, the non-clean surface on the left will have a lower SRI value compared to the one on the right. Despite, on color selection, when you're looking at brochures, data that is applied by a supplier, despite the SRI value being, achievable to a certain requirements, right? So the cleanliness of the surface is definitely going to affect how it performs when it comes to, a long-term heat absorption from the solar radiation. Okay, so this is one of the practical things that you should consider as well. Okay, so just now I mentioned it's not as simple as looking at the colors and choosing a darker color, then definitely it will be worse off. So if, let's say, for certain design intent, you want to have a darker shade color. So of course you can look through and read through different colors scheme, right, to reach the one that has a higher SRI value, that is still considered so-called the dark shade. But another thing is that that's not really commonly known by a lot of architects, is that there are colors that looks the same but not thermally optimized. So this is where the cost consideration will come in, right? You're choosing colors of the same shade, but how should I choose? Okay, so over here, I'm showing you the impact of thermally optimized paint versus a non-thermally optimized paint, and so on. So of course, these are data taken from our test back in Australia, but it's actually to give you a level of awareness, right? So this specific example that I'm showing you here is a color that is only produced in Australia. It's called woodland gray. Okay, so this color itself is thermally optimized. So what happens is that when you're thermally optimized, it means that even though you are having the same shade of color, you're able to lower the surface temperature of the cladding, meaning having a high SI value. So if we compare to non-thermally optimized, so-called same shade of gray, we don't call them woodland gray in this case, then you see the surface temperature can increase from 80 degrees Celsius to close to 90 degrees Celsius. And of course, if let's say you compare to the worst of the case, it could be looking at slightly above 90 degrees Celsius. Okay, so don't underestimate the increase of 1 or 2 degrees over here, because that could affect how you turn on the air conditioning and so on. So that is the impact of choosing color. So of course, if let's say you are looking at it from a cost side, right, then this is the test and also the data that was gathered. So in terms of the cooling load in terms of watt per meter square, okay, a thermally optimized version can give you around cooling. You only require 16 or around 16.5 watts per meter square of cooling load. So compare that to a non-optimized gray color, right? That is very close to woodland gray. Then you're looking at somewhere in between 18 or close to 19 watt per meter square of cooling load. Okay, so you can calculate the percentage there. And of course, if let's say it's the worst of the case, it could be above around 19.23 watts per meter square. Of course, translate that again. If let's say you're not looking at just cooling load, you're looking at colors. Sorry, the cost, right? So we did run some simulation, or rather calculations, with a lot of assumptions to compare across the colors that are readily available in Malaysia. So this is a calculator that we developed for our own internal reference. So to raise awareness, say of choosing of different colors at different SRI value. Okay, so I'll do 2 exercises over here. So the first is to compare a light color with a dark color shade, across our existing color. And another one, I will compare a thermally optimized, locally available color to a non-optimized color, right? That appears the same shade but then different SRI value. Then you can see, the cost impact and so on. Okay, so these are all quite, I would say, self-centric, meaning we are only considering my electricity bill, but we do not really consider the overall of the environment, right? So this is more of a selfish way of looking at the cost saving. Okay, so it does not consider the overall environment consideration. But of course, overall we know that higher SI definitely is going to be better. Okay, so here what you're seeing is a comparison of off-white and also Cape charcoal, the spectrum. So off-white with a SI value of 80, and then you have a Cape charcoal with a SI value of 20. Okay, quite a big spectrum. And from here, our calculator, we put a lot of assumptions, including electricity consumption, the average consumption rate, and what's the cost of the electrical tariff, basically the tariff. Okay. Then from here, we assume the house is a single-story house at a 300 meter square footprint, right? And from here, we calculated the energy saving, right? If let's say you choose a higher SI value, color of a roof, then you get somewhere around 7,000 ringgits in terms of saving over the 5-year span. Okay, in terms of electrical saving, and you could be looking at around 11,500 ringgits of saving for 10-year span. Okay, just by choosing the color. And of course, there is a possibility, because you do not need to increase the cooling intensity, or rather the horsepower of your air conditioner. So you can actually potentially save on the the power, the air conditioner unit. So again, these are being normalized and also cut into small sections. Of course, in today's commercial market, we know that there could be a jump between horsepower. So this is just a calculation to give you an idea, right? So you could be looking at 2,400, 2,500 around there of upfront HVAC saving in terms of buying a higher horsepower or rather air condition. Okay, so like I said, this is just an exercise. It's not to be taken as true. It's just an exercise to tell you and to inform you the impact of choosing the right choosing the right color. Okay, so of course the same scenario, but then everything will be will stay the same, including the footprint of the house and also the height of the house, because single-story house is to show you the extreme of it, right? Okay, so armor grade with SI value of 48 versus a generic gray that looks similar to armor grade. It's not thermally optimized. For example, SI value of 40, right? So we did measure. I mean, we did consider all these non-optimized color to show you the impact, right? So over here you can look at the impact is lower because you are actually choosing in between two different shades of two same shades of color, but different in terms of one thermally optimized, one non-thermally optimized. Okay, so you are looking at based on our calculation, looking at 1,700 ringgits of saving for the thermally optimized one within a span of 5 years, right? You can do your division, right, to analyze it. Or you're looking at 2,660 ringgit of electrical saving for over 10 years. Okay, and possibly you're looking at upfront hatchback saving of around 700, right? So again, practicality, is another question. But again, today the exercise here is to show you what could be possible from a selfish perspective in terms of energy saving. Of course, if let's say we are considering the whole township, probably it's not a zero-sum game. Probably it will have an even larger impact in terms of better environment, cooler environment, and so on, right? So that's where a lot of factors come into play, which we will not dare to give any assumptions. It's too much to give an assumption to, right? So again, to condense all that, Zaidi, I will ask you a question, right? What do you think, right? Based on all that we have presented, the U value, right? The sound transmission class, the SI value. Have you seen, a good case that is, really can be practically applied to Malaysia context and has been successfully done, and involved with Unison, in Malaysia, so that we can show that it is really possible in Malaysia.
Okay, thanks, Rocky. I think it's a very pertinent question. In our case, I think the United Season or Kawa Roof have involved in many airports. We had the privilege to do a lot of airports from part of Senai Airport, Melaka Airport, KLIA, Kedah Airport, I think Kuantan. In this case, one of these lights, if you can see, it's actually the airport in Sandakan. I think this airport in Sandakan. And when you talk about airport, most of the time there's one of the building that actually work in 24 hours kind of situation, especially international airport. It's 24 hours. When it comes to 24 hours, they use a lot of aircons to cool the building. So in this case of Sandakan Airport, for example, we have a design actually to achieve the U value at 0.32. Which is very slow. And as I said just now, when you have the thermal performance, you also have a sound transmission performance, which is in this case we achieve at SCC 42. And what you have just said just now very clearly that choice of color are very important. So in this case, the wanted to use white, but I think it's too clean, I guess. So Gul Grey was the next in line. So we have SRI CD6, which is very good, and we have, I think, the longest length of this roof, I think it's about 30 meters. So we are using thickness 0.6 in this case. I think the two information that I put on the last one, the roof length and thickness, will relate to what we're going to talk next in our slides. Okay, so this is one example. Then I think we have many examples. I think the project in Siem Reap in Phnom Penh, I think they are using white color as part of the design. I think it's merely because, again, as I said, it's 24 hours internationally, and the aircon have to do a lot of savings in this case. So we go to the next things. Looks bad, Rocky. This is near our place. What do you think about it?
Well, just now you mentioned when it comes to changing weather, right? I think changing wind is relatively invisible until something happens. Meaning you have gusts of wind, you don't really see or feel. I mean, you do feel it, but then people normally question and start asking questions when things like this happen.
Yeah.
But I think it's just too late or too reactive for us to ask the question when things happen. And I think from this case, and then just now you mentioned airport, right? So we have to be more proactive in terms of probing the question and constantly asking whether the current design and current practice and current way of procuring the components, whether it is relevant as the I'll say when we are describing climate change, right?
Yeah.
There is a lacking in terms of time sense, right?
Yeah.
The pace of climate change is not constant, right? Where the increase of temperature is not like 1 degree per year. I mean, if you look at the history, it's accelerating, and our buildings are designed to last quite some time. I would say. Wow.
True.
So we had to design probably 10 or 20 years ahead to make sure that all these are accounted for. And of course, the short-term cost is something that we have to really talk about, and especially to the investors who are paying the money, and really put our effort in convincing them why they should invest more, right? I think at the end of the day, it's about assurance.
Absolutely, Rocky.
And if you look at insurance, they have all this data to tell them, okay, how do they insure? Same. I think over here, I think what Zaidi, perhaps you can share a bit. How do we actually design the roof, and what are the considerations that we should consider in terms of to make sure that it will withstand higher wind load and all that?
Absolutely, Rocky. I think the Mr. Chairman initially started with saying that there's few elements of this climate change. Water have risen very high in Penang, and also the heat, and also now we're talking about wind. So if you notice, this is a car park somewhere in Shah Alam. Actually, we're talking about high wind normally on the high level of a building or even land or something like that. But I believe this is because of climate change. The wind has also been very strong at the sea level, even in the ground level in this case. I think, and just to tell everyone and the architects, if you notice this from these photos, I would say that the roof has performed where the structure failed, because the structure has been blown away together with the roof, where the roof's intact with the structures, and we always get blamed because of the roof fly off. Okay, just to make sure that everybody understand the situation that we are facing right now. Okay, now under MS 1553-2002 Code of Practice, there are a lot of wind loading. So how we determine wind loading? I think in the early days of my experience in industry, we're talking about 25 meters per second wind. Now I was told it has been increased to 28 meters per second wind. But how do we determine? I think in our industries, that a lot of people talk about tables, wind table and ATA, especially. This is one of the way that you can look at it, but it doesn't basically work to some extent because of this climate change. But in Unison or in Kawa, we go a bit further. Instead of calculating the force of everything, we have sent our product to what we call it negative pressure test report in SIRIM. I think when we did this particular test, Syria has not come out with the so-called Malaysian standard of methods testing, which is they eventually came out, and Blue Scope and Kawa are part of the committee members, which is we created, I think, MS 2523 method of testing, method roofing, method decking in Malaysia. So this is one of the example that when we do a testing, I think this is one of our profile, our standing seam profile using a 0.6 thickness. I think again thickness is important here, and of course zinc at this moment, because we are trying to see the impact on force. You're looking at it of course on this particular test, we actually push ourselves that the purlin span to be spent as maximum as much as possible at 1.7 meter on, and as you know that engineers in Malaysia we design 1.2 to 1.5 maximum. So but if you look at this profile, actually perform to have a negative force by hydraulic force and calculate the force, that it need almost 9,500 Newton before actually it dislodged from the system. This is 1 ton, almost a ton of loads, and we're still trying to convert it into wind velocity to come up with actually this actual instead of calculating the actual test by hydraulics or system in CRIM, that it take 1 ton of force to move the roof from the so-called accessories, in this case our houses. So it's quite a big force, you know. So, and again, as I said, it was test into the maximum at 1.7 per span. So we have at 0.6 just now. Also, we test slightly lower, just to make sure that the thickness are being selected properly when you design a building. That depends on where you design it. So in this case also, we have reduced the thickness from 0.6 to 0.48. Even at 0.48, the system actually dislodged actually at 6,500 Newton, which is almost more than half a ton of force. In this case of so-called wind speed that we're talking about to dislodge the system or the roof from the system. So we did this test for the sake of actually now the climate change have we know that the wind are getting stronger and stronger. Then again, this is to make sure the designers eventually understand the importance of thickness and the importance of design and selective or the selection of profile that to be selected in their design. Because I mean, in Penang now there's a lot of big what you call it factories with a very open area, which is we have a lot of wind, and in Penang also they are very near to the sea, and the wind from the sea sometimes can be very, very strong to some extent in other way. And of course, in our industry, there are many profiles. As I said, one of our profile that actually originated from Japan, which is actually subjected to typhoon, to very high wind. So we brought it here to it's not only because of the wind. I think this ability, this system to span. If you look at this test report, it is we have using the same thickness 0.6. But if you notice the test span mentioned on the left side of the report, actually you are spanning at 3 meters, okay, twice as far as a normal design. What you call it? Twice as span as normal design in locally been designed by the engineers, 1.2, 1.5. So even at 0.48 or 0.6 mm BMT, the thickness, the force to dislodge the system actually at 13,200 Newton, which is almost 1.3 ton of loads or force to move the system from the roof from the system. Actually, it's a very high wind. You're talking about almost you know, F3 kind of wind speed in Malaysia. So this is one of the systems that we have, and of course, we supposed to compare probably when we have a load, and there's one of the element that in this our industry talking about deflection. So the deflection is very important, because if you deflect more than what it can take, it won't go back to the original shape. So in this case, our KZ was slightly less than the R650, because as you know that it's a more, how to say, the rate is higher than the KZ. But even at almost a ton of force, only it almost half a ton is only deflect about 13 mm or 14 mm in this case, and the 650 has performed very well at even almost a ton of force, talking about 12.35 mm. So until it dislodged from the system, only it will be withdrawn from the frame. So deflection is one of the elements that, because once you have a deflection, this is where we're going to talk about water. Everything. When you deflect, it doesn't go back to the original state. You will create a water ponding. And you know, water ponding is one of the elements that the material will have effect eventually in the performance. Of course, we also compare. You can create, I think, as I said, you select the proper, correct profile and a correct thickness. In this case, you have two thickness, either 0.48 BMT or 0.6 BMT, so they have a different result. But of course, even at the lowest at 0.48, you still need about almost a ton plus before it actually withdrawn from the flip, or it fail to take the so-called the force of wind in this case. Okay, Rocky, as the comparison talk about the thickness, everything, how important are these thickness? How do we actually put a proper thickness in a proper design to make sure things works properly in this case? Because I think this is your expertise. And then I believe that it would be more information that from the manufacturer of a coil, that how does this thing works, and the best way to specify it, and even the best way to select in terms of material thickness in this case.
Well, Zaidi, you asked a really important question. I think when it comes to base metal thickness or thickness in general, I think because you don't see it, so a lot of times, you know, we do encounter lack of specification on this front. And Zaidi, the data that you have shown earlier, the test data, you know, which is more important than, you know, calculated or rather a simulated data, because failure, you can never calculate failure right, because failure is chaotic, right? So whatever they have shown is very relevant in terms of how much force it would take to fail a certain profile or certain thickness in certain profile. I think just to highlight back your slides is that I think just now you shared a slide of you know, different thicknesses that would have an impact in terms of you know, the pull-up stress, so-called the wind load line. Of course, I think in Penang, you know, aside from, you know, the big developers who has you know, the budget. I mean, because the budget for, you know, investing into the machineries underneath the roof is actually much more than the architecture's you know, components. So that's why they are willing and they want to spend more to secure the building itself. But of course, there are also you know, buildings that you know are not do not appreciate so much on the, you know, the roof part, because, you know, it's taken for granted, put it that way, right? So most often the questions come into play when they want to do value engineering, they want to do cost saving. So when they want to do cost saving, the sacrifice is on not the profile type, because the profile type itself, you know, is very visible. So when you change or downgrade, most often you can see the impact and you can really see it. But then when it comes to base metal thickness, people don't really see it, especially in this case. You know, in this context that we are discussing, climate change. Like I mentioned earlier, we are designing for, you know, the 10, 20 years ahead, right? Unless you plan to change your, you know, roof every 10 years, then you can reevaluate, you know, how much you want to, I mean, what is the protection or what is the strength that you want to use every 10 years. But I don't think, you know, any investors in the right mind would want to change the roof every 10 years, right? 20 years is also considered a minimum, right? So in this case, base metal thickness is really crucial for you to actually you know, consider when it comes to designing for the future. Of course, I'm quoting JKR's standard specification document over here. Of course, from JKR's perspective, you know, they would, I would say they have a guideline for all their JKR members, you know, across the country, to make sure that adhere to this bare minimum. Okay, so this bare minimum has also been practiced in the market, but then increasingly, I think a lot of people, you know, lost sight of it because of you know, the highlight on cost is much more prominent than what is the specification. So just to recall your memory, so in JKR standard, the roofing bare minimum base metal thickness is 0.42, right? And for wall cladding, if you use it for wall cladding, then the bare minimum that you should go is only 0.35 mm base metal thickness. And if let's say you really have lost touch in terms of this industry or this type of product itself. Let me just remind you, base metal thickness is not referring to the overall thickness of the material. So this is really crucial why we should specify the base metal thickness instead of overall thickness. Okay. I put you a scenario, right? So imagine you have specified a certain thickness, say for example 0.48, the thickness that Zaidi has tested and specified in the slide earlier. So what happened is that the practice is not ideal, in this industry. There's always loophole. You specify 0.48 thickness without specifying its base metal thickness. What will happen is that when they do sourcing, contractors propose 0.48 is commonly understood as the overall thickness, meaning they will, if let's say you specify as base metal thickness, otherwise if you just specify as thickness, most contractors will take it as the overall thickness. Okay, so but the overall thickness, as you can see from here, it is composed of the metallic coating, the paint layers and all that, and depending on different producers, they can have various thickness of the alloy layer, the thickness of these two separate types of components in the whole coated steel. And as you can see from here, this coating itself occupies a fair bit of the thickness from this overall thickness. And base metal thickness, of course, is the main part of the thickness. Yeah, and to talk technically, the one that provides the strength, why Zaidi only specify base metal thickness and not overall thickness, is because it's rightly so in the test report. When Searing do their test, they will measure the base metal thickness instead of the overall thickness. The simple reason is because technically, those coating on top and bottom does not constitute or does not help with the strength. Okay, so in this case, base metal thickness is the one that will contribute to the strength, right? How strong it will grip on and latch on to the structure. And the scenario that I described to you earlier, if let's say it's just overall thickness 0.48, what will happen? What will happen is that naturally you get a roof with a base metal thickness that's definitely lower than 0.48. That is for sure. That is considering that the contractors that you are sourcing from is very honest with you, right? But bear in mind, the industry is not showing best practices. Yeah, you don't have all the best actors, or there are a lot of bad actors out there. I'm not pointing names and whatever, but you know what I mean, right? So it's very hard for you to source a good product in terms of specification if let's say you do not specifically point out the base metal thickness that you should source from. Okay, and of course this needs to be carried on, right? Because we have new workforce coming in, and most often they will lose sight on all these things because they are not the specialists. We are the specialists. So we have to constantly be aware and be educated, re-educated when it comes to all this. And it is a really timely topic for us to talk about it again because of a few reasons. First, of course, topic of the day, climate change, right? The increasing wind speed, that's unpredictable and it's everywhere, right? That will jeopardize the roofing. Okay. Second, the increased price of these commodities, all these different components, right? That will lead a lot of people to consider how should they source. But again, those commodity prices are just fluctuating, but we are not designing for the short term. You see, we are designing for 10, 20 years, and down the road, if let's say anything happened, you will easily spend double of what you spent earlier, right? Because you need to manage disaster, you need to manage the how people look at it, the building, right? So all these come into play, which are not part of the consideration when people look at cost saving or value engineering. which should be honestly be on the table during the discussion, right? And with data that is shown by Zaidi earlier, you are able to use this information, take advantage of all this information as part of the decision making, right? So I can show you, some of the, of course, less severe case lah, of insufficient base metal thickness. Of course, this is not every day you see a roof collapse, immediately after installation, right? But a minor one, you will see here and there, like roof dents, that is caused by lack of thickness. Bear in mind, this is still widely sourced and widely used in the market because of the retail market, right? In project, there are specifications, right? So people tend to choose good product because there's specification, because there's architect here, right? And you guys make a really good, gatekeeper, as a gatekeeper, right? To source the right product for the major investors. But for retail purchasers, right? They are lacking information, they are lacking understanding of the product, right? So most often it's influenced by how the person sells to them and also how much they can afford. And most often that is where we see, roof flying off because you look at the building, it's kampong houses or rural houses, because they lack all this understanding, you see. So I think professionals, we should be one step ahead of that. And when it comes to this changing wind condition, definitely you need to design ahead, right? And consider the scenario ahead. And again, come back to you, Zaidi.
Yep.
Of course, base metal thickness, and also just now you mentioned different profiles and mainly for airports, right? Have you seen the most extreme, success stories that you have done and been involved in, and what is so critical about that roof that you would like to feature today?
Yeah, okay. You have said well in terms of the thickness that required. I think one of the notable project that we have done, I think is a mast hanger. We call it mast hanger 6. I think there's 2 hanger over there. The far on the photo was we call it hanger 5. The nearer was hanger 6. Proud to say that a point that this is hanger 6, or we call it the A380 hanger, was the widest columnless hanger in the world at one point. They have a column free span at 230 meter wide open space. Again, when you have a wide open space, you have a lot of wind force. Especially airport concern, that we have a lot of wind force. Then this thickness of 0.6 selected because of that, and also the design of the support actually at every 2.4 meter, again twice as far as normal 1.2 that normally designed by the engineers. Then the roof length, if you look at it, is one side of the roof length actually 115 meters at the pitch of 2 degrees. This is the next thing we're going to talk about. How do we handle the water flow of we have such a big design building in this case. We'll talk about it next. Right, this is another example. Of course, the Hatsu transmission plant. I call it the Hatsu. It's supposed to be Produa anyway. So again, this is slightly lower thickness because it's at the lowland area in somewhere in Bismillah. So of course, the roof line is 88 meter. Very flat roof at 2 degrees. Actually, we can do at 1, but they decided to do it at 2 degrees. I think just to be safe, but. We were quite confident 1 degree will be it works as it is, and look at the photo alone. Because of this new industrial area, you have a lot of open area. You are subjected to very high wind to some extent because open. You can see the hill on the other side. It can create what we call it turbulence, airflow when come to a tunnel effect to some of this wind. But Alhamdulillah, I said it worked well up to now. And well, you guys still have the Azia Produa engine all the way nowadays. Okay, Rocky, have you stuck in a jam in KL nowadays? Everybody's scared. For the past few months, we have at least 4 times flash flood. And this is, again, the chairman has been said, one of the first element that water have rise. In this case, rain has been getting higher and higher in terms of intensity. Hope don't stuck anywhere in in KL lately, okay? What do you think?
Well, if you ask me, of course, everyone, I think everyone within the tropical region would definitely feel in some capacity how there are increase in rain intensity, or rather frequency of rain or precipitation, as the technical term. This again will point back to how we will look at the roof design and to make sure that we design it to mitigate all these catastrophic or chaotic events from happening. But I think one thing is for sure is that we have increased rain intensity.
Absolutely.
And when that happens, there will be minor cases of, say, leakages and whatnot. Sometimes people, the building owner, manager, maintenance people will just brush off, be like, oh yeah, this is only happening once or twice. But I think it's good to be aware, how the roof can be designed, and rightly so, the profile selections, right, that will be relevant in this case. And of course, we'll be talking about how the material get impacted. Let's say there are those, just minor leakages happening. In the long term, it does affect the building performance. So, Zaidi, maybe you can share the facts and figures and what we can do to mitigate this intensity. This new so-called new record high in terms of rain intensity.
Yeah, Rocky. When you talk about minor leakages, in our industry, we have a say. As you said before, nobody actually really, considering about roof until it leaks. When it leaks, everybody's looking at us, say, hey, why is it leak, kind of thing. So quickly, as I mentioned earlier, due to climate change, we believe I think it's 100% of climate change. And in Malaysia now, we never have, Selangor had never been flooded, I think, unless you are in Kelantan, which is what's called it a yearly event, which is it's not an issue to them. So December last year, 2021, we have suffered, Selangor, when I said we are in Selangor here, we suffered the highest rain intensity was 300 mm per hour. Actually, at 300 mm per hour, you already have that kind of flooded. But actually, what makes it more even more severe, it is because that it keep on raining. It keep on raining for 4 days until, of course, I don't want to talk about the drain or the river itself, and Chairman have mentioned even in Penang now, once you have the water rise from the sea, I think the flow of water will be very slow from the river to the sea. So this is again, in our industry, what are the things you must consider? I think in the design, in the architect design, again, Penang have I have seen Penang lately a roof that actually 100-meter long, in terms of a design for a big factory. So, but in our industry, actually, you can actually calculate in terms of how to, when you design things, we will advise the architects that looks, you have this roof design, and you have to look at the water intensity you're gonna face. I mean, we call it in our industry, in our company, we call it the determination of the water flow depth for profile. So in this case, you can actually simplify the thing in terms of if you look at that, the so-called parameters you're talking about just now, talking about rainfall in Selangor 300 mm per hour is already flooded like that. We try to have some safety factors. In this case, we created, when we do a calculation, we take at this moment at 350 mm per hour. So the gradient, we look it at example like 2 degrees as low as possible, even 1 degree in this case of this profile KZ 200. So we have a length of 100 mm. So some of you guys understand when we in science class, we have a lot of formula, talking about cheesy formula, Gankulikuta, Bernoulli's, everything. So in this case, you can translate this formula, or we call it hydraulics during our university study. So with hydraulic, you can calculate the fluid, how the fluid works, or how the fluid react in terms of the flow velocity. You have the what call it the slow rate of the flow of the water. So quickly after, don't have to understand the formula so much so, but once you have simulate the formula, granular, you actually can understand, or you can understand the what you call it, the height of water, that it doesn't flow or leak overlap. I will show you why you call it overlap. See, in this case, in this case, when you have that parameter 350 mm per hour, 100 meter length at 2 degrees, the water actually at 21.8 mm in height, is it? Okay, so what happened is, when 21 mm in height, actually this is to show that your water level at your roof at 100 meter almost towards the end, the level is actually at 21 mm rib height approximately. So in our industry, people always say, what is your rib height? Rib height, what is your rib height? Rib height, of course, the KZ in this example, we have like 65 mm rib height, but the water should actually enter your roof. One, it reach what we call it a side lapping. You know, in this case, is KZ given a 65 the rib height, but the side lap is actually 41 mm. The water shouldn't reach this 41 mm height level, and then it start leak, what we call it side lap leaks. It's not, you know, you don't create a hole on the roof, but even side lap leaking. You know, so this is a consideration when you design a very wrong roof, or how some architect that I met before, can I do 1 degree or 0.5 degree? Yes, you can, provided that you must select a proper or a correct profile, right? So I put another example. So in this case, one of profile, we call it clip block. Everybody knows clip block. Kita always clip block. So if we put a similar parameters, 300 mm, 350 mm per hour, 2 degree pitch, which is most industrial players say minimum 2 degrees, and then we try to you know, this is over promise, talking about 100 meter length of roof. So at this 100 meter length of roof, if you notice, we call it summary, the depth of water flow along the valley or through the roofing actually is 21 mm rib height. So again, in my experience, in terms of a clip block profile, I think the highest will be, if I'm not wrong, was 43 right now, some of the manufacturers, and the lowest I was, if I understood, it was very new, about 25 mm. I don't know why they create clip block at 25 mm, but anyway, in our profile, again, the rib height actually is 41, but where the side lap, this is the side lap where the water can enter into your roof. Actually, it's only 21 mm or 22 mm. Now, once you have that rainfall intensity at 350, 2 degrees, and 100 meter length roof, you are designing 100 meter length and you specified using clip block. So the water height actually is 21, where your side lap is 22. You don't have much safety factor in this case. So you don't really, I think this is a no thing to design a roof. Once you don't have that much safety factor, you are actually creating a disaster to be happen just in the future, you know. So again, most of the industry player, like Rocky was saying, there's a lot of bad actor. Rocky, bad actor normally win Oscar, you know. but whoever who don't win, don't be sour faced. But what I'm trying to say, that if they said, the explanation must be right. You know, oh, my rib height is 41. You don't worry, your water is 21. You only have 50%, but that's just not the case. The case is, you have to understand the technical part of it, your side lap. Once you reach your side lap, you actually enter into a land of disasters on your building. Rocky was saying that the nobody looked so much so on the building, but on the machinery inside was very expensive. So this is how you create how you determine what kind of profile. And at the current what you call it, climate change that we face, 350, maybe, you know, I don't know Penang, now maybe you get 380 or 400 at one point. We do not know. Rocky was saying we design for 20 years down the road. We do not know, you know. So this is consideration when architects designs, when architects try to use what profile, we will be able to provide you with the information and the right way to specify the thing, right? So in an example on the best of the best, what we call it, if you use my just now from this Kawa R650 all-oxygen system have the best in terms of wind uplift. And this is the same case, same parameter that we put for rain situation or water situation in this case. So the water actually has 21 mm height, where the site lab is actually at 100. I think this is so much safety factors, you know. But it's not only the water in this case, because we have three elements just now. We have wind, we have water, and we have thermal. So thermal, I think more or less how do you use the insulation, but the two elements where the wind just now, the force of before it dislodged from the system, and also the water. So this water actually you have basically used actually only 20%. Oh no, sorry. Yeah, almost 20% of the performance of the roof. So you have no need to worry. In fact, if it's 2 degree was a bit high to some extent. You can even reduce your angle at 1 degree in this case, and it will probably still perform as it is. So this is this important thing that to understand that in this situation of climate change, the wind and the rain have so much changed the way that we design and how we adapt our roofing. And roofing don't change like fashion, you know. You don't change every year your profile, you know, kind of thing. So it will be used for the next 10-15 years without changing so much. So the data or the information must be correct. You won't be able to get a new type of roofing next month, or we call it in terms of fashion. You got winter clothing or summer clothing, that kind of thing. So this is the other case around. When you talk about roof, again, this is an example. Okay, so it is an example that building, when it's a huge building, you're talking about roof at 161 meter and roof pitch at 2 degree. Even so, that we calculated at 300 mm per hour in Tanjung Malim, the water level is only 28 mm. In terms of the water level. So the thickness of 0.8, I think some of you guys would think a bit overkill using at 0.8 PMT. Look at the last information. The purlin span in this building actually is 5 meters, not 1.2, not 1.5, not 3 meter. It's 5 meter purlin span. Basically, there's no purlin. This is an I-beam in our case. Again, this building was installed, I think, in 2010 or 11. It has been gone through so many, you know, changes of rain or wind in Tanjung Malim nowadays. So, Rocky, I would say this is among the notable project that we have done, and at that point of time, we have seen a future how things will react in the country and the environment in this case. Well, this is another one in northern, I would say, Kedah in Kulin High-Tech. So again, the designers created a very low pitch at 92 meter roof length, water level at 18 mm, which is no issue up to now. And again, the thickness is 0.8. Again, to spend the purlin, that kind of things. Yep. Okay. Now, what is the water level higher than the profile? What kind of effect or what kind of consideration or what we should look into that affected the material performance itself that we can add into this presentation on climate change? It will happen one of these days. So when the water is too much and the profile unable to cater for the water in this instance.
Yeah, well, Zaidi, just now you highlighted all these say different choosing of different profile, right? So you can see in certain scenario the water level is just too close to the site lapping, right? So as just now you mentioned, if let's say it's over, you know, disaster struck. So but what kind of disaster, right? So it's not as catastrophic as the wind, where you know a gust of really strong wind could uplift the whole roof. In terms of water, as I mentioned, it could be just you know, leaking, you know, here and there that can easily be brushed off, you know, and until the point where it's just too late, right? So this is where it's quite dangerous. So if let's say you're designing for those big warehouses, or rather, again, because of U value, you need to achieve the high U value, so you use insulation. The side lapping, water leaking will definitely affect the material. Why? It's because if let's say there's any water leaking through the side lapping, what happens is that the insulation material will start accumulating all this water, and because it's contained within a space, right? So the water will not easily be evaporating or escape from anywhere else. So this create a very dangerous scenario, right? Where water could be accumulating and all these water retaining substances. And in the long term, it could accelerate the reaction of the roofing material, right? Any kind of metal with the existence of all this moisture, it will start reacting faster than it used to. Is expected, and we have seen failures like the one that you have seen on this slide, that it could be as short as 2-3 years and so on. So I think when it comes to dealing with water is very, very absolute crucial, right? Because if let's say it happened where the water is corroding roofing sheets, I mean it's still minor compared to, let's say, it's attacking crucial component that are locking the roofing sheets down, for example, like fasteners, right? So it could start also entering through the fasteners. Let's say it's just going over the rib height, right? And of course, this image that you're seeing is combination of the earlier one, lack of base metal thickness, and then also on-site practices, so overdriven, and it's lack of thickness, so it gets all this indentation after the installation. And what happened is that if let's say water seep into it, then you get all these fasteners corroding faster than usual. And once it starts corroding, you can easily expect the fasteners to appear to still be intact, but whether there's any locking strength remaining on this fastener, it's only a matter of just go there, use your finger and pinch the fastener and pull it out. I've seen this case, and it's quite a surprising realization when that happened, and then you'll be like, oh, how should I deal with this, right? So of course there are all sorts of failures that arises from abundance of rain and especially during around say industrial area, right? Rain does not just come as pure rain now, it dissolves all these industrial emissions, right? And form sulfur dioxide and so on. So it forms acid rain. Yeah. And all these could also accelerate the corrosion of the components, right? So this is some of the examples, right? Some examples. So when it comes to dealing with water, one of the most straightforward thing is to get your profile right first, and to get the thickness has got both the wind uplift effect as well as the water carrying load effect. And of course, after that, what needs to also happen is that you need to look at selecting the right components to go with it, right? So for example, the fasteners, right? We have constantly emphasized on selecting the right fasteners and so on. So which will have a certain impact to how the roof perform, right? In terms of whether it be leakages or rather wind uplift and so on. Aside from that, there are other smaller components that are not directly relevant to roof, right? Such as solar panels. But so happen that the solar panels are installing on the roof. So components of all these solar panel systems, or the arrays, right? How to actually mount it on the roof is also very crucial. Coming back to the science part of things, right? When it comes to selection of material, we had to always be aware of the existence of galvanic series or the galvanic reaction. So it does not just restrict to just 2 or 3 metals like steel, aluminum, and zinc. It happens to all metals, to the point where if let's say you're married, the gold rings that you wear on your finger, or any other things, right? So any metals, if you pair them together, that's what we call galvanic series. Of course, galvanic series has got other conditions, which one of it, crucially, is water, or we call them scientifically, we call them electrolytes, right? With the condition of these 3, and of course, technically, if you contact together, then it will have what we call electrical connection, right? With these 4 conditions together, right? Different metals, which considered 2, electrical contact as well as electrolytes, which is rainwater, reaction starts happening, the galvanic reaction, and you have to consider, whether the components you have is correct or not. So one of the common sites, which I think we have been, trying to educate the market, is that because, in Malaysia we do have a lot of lightning, especially throughout this region. So there are lightning conductors to be installed, and rightly so. This system itself is normally in charge by the engineers, right? So the original so-called the material that is still being preferred is copper, right? But when it comes to copper, right, there is a galvanic series that is detrimental to the coated steel roof, right? Where you see all these things happening, right? So this has to do with, again, the rainwater that falls onto the copper and then leaking it, and also some of the ions that are coming off from the copper, flowing into the water and then contacting with the roofing sheets, which is made of steel and aluminum and zinc, right? And all these 3 metals will be susceptible to reacting with this copper, and then eventually leading to all this corrosion happening prematurely, right? It's not as intended. Okay, so of course, this needs a bit of convincing, especially engineers. So we have seen and have encountered engineers who are open to suggestions and willing to consider alternatives. But we have seen also, engineers who are not open to all these options, right? So it needs to at least have a discussion rather than just assume that this will not happen. They will just be stubborn, right? So of course, what can replace copper is aluminum, right? So aluminum in the galvanic series, it is very compatible in certain front to steel, because galvanic series wise, it will not damage the metal. It will not, the steel lah. And in terms of conducting electricity wise, it is not as good as copper, that's for sure. But with the correct dimensioning, it is able to do the same job as copper, right? So that you are able to protect the whole building from lightning strikes with this alternative material, but at the same time, not damaging the whole itself. Okay, so I think yeah, so that is all we have to cover today. Yeah. So I think if I may summarize today's sharing, is that I think Zaidi, you mentioned strongly about the U value calculation, the roof systems and all that, which is very crucial in terms of making sure that the building is kept cool, right? And also with by doing that, the side effect, also called the benefit. Side benefit would be sound comfort, by measure of STC. And of course, from the color choice perspective, I think solar reflectance index has been one of the key factor in terms of the initial defense against solar radiation heat gain, right? And of course, when we talk about wind uplift due to the changing wind condition, and I think you have shown a certain tests, all right? Yeah, certain tests to show that the test result is, what kind of test and then what kind of profile is going to affect it. We talk about the base metal thickness, right? That could affect wind uplift and rightly so is shown. And last, we talk about water runoff due to selection of different profile and also the changing wind condition. So all this has to do with how we design for the changing climate. Okay, I think that would be my key takeaway from delivering this session today.
I think there's more when you talk about climate change. I think there's more thing to say. But I think in this knowledge sharing or presentation today, this is what we can do in our parts in the industrial concept or in our part of business. So I think there's more. We should share more if we can come up with something that relevant very much. I think water, winds, and all these energy efficient. I think this is three main elements that we're going to talk today. So I wish to say thank you to Rocky to be my wingman today, and Pam Northern, ARB, thank you for arranging all these things. So I think it's time for Q&A for us.
Okay, thanks Mr. Rocky and Zaidi for your this informative presentation on designing building with metal roofing, which adapt to the climate change. So I think to not wasting our time, now we start the Q&A session. So whoever have any question to our speaker, you can raise your hand, then unmute yourself to raise your question, or you can just drop in the chat box. Our speaker will actually answer to you. So is there any question to our speaker? Okay, any question from the floor regarding this metal roofing design? Okay, I think before the question from the floor, I think I got some question to the speaker. Okay, here I wish to understand about SRI. First, from your slide, actually, and I think from most of our understanding, only off-white color can achieve SRI over 78, which is a requirement from the GPI for the greenery and roof. So I wonder, is there any other alternative can be achieved this 78 SRI? Maybe a bit dark color with thermally optimized paint or any alternative?
Yeah, maybe thanks for the question. So if you look clearly on the GPI rating tools, right?
Yes.
It is highly dependent on the roof pitch. So of course, if let's say you calculate the 2 to 12 ratio, I think you get a roof pitch of around 9.7, 6.7. So any roof pitch above that, I think there is a lower SI requirement, which is around at least 20 or and above. Yeah. So of course, when it comes to requirements, right? If you want to score the point, it depends on the design. But again, coming back to your second part of the question, which is about SRI of higher than the 78. We do have two white colors in our catalog that are higher than 78, and you can look on our color charts to get to the specific colors. But aside from that, also there are available. I mean, there are colors that can be produced as, but it depends on the whatever project that you have that has such higher requirements. requirements. But yeah,
I mean, any darker color with the thermally optimized pen also actually possible to achieve 78, is it?
No. Any colors that are darker, it will be
A bit
very
darker from white, I mean.
Yeah. Any colors that are other than white, for example, gray, right? It will be very hard for you to get that number because, like I mentioned, there are two components to getting the SI value. One is solar reflectance, another one is thermal emittance. So the solar reflectance part is a huge part of calculating the SI value. And if let's say that part suddenly you have a gray color, then the solar reflectance drop quite a lot. And that, I mean, even with the optimized system of paint, there's a upper limit to where it can go. So in a way, if you want to achieve a SI value of 78, most often you are having a restriction in terms of color selection. So
I see. So understand that zinc column roofing sheet also, because of without the color coating, so it's, even though it looks like very light gray, but also cannot achieve SRI 78, is it?
Yeah, we did measure the SI value of zinc column. I mean, measure means we measure the solar reflectance and we measured the thermal emittance, and then did the calculation like quite the standard. But it varies because again, it comes down to the appearance, how consistent is the color. So for zinc column, if you look at it, it is kind of what we call spangle finish, meaning there is some part that is darker, there's some part that is lighter. And on average, based on our measurement, we did, I think the calculation yielded to somewhere around 60 to 70, somewhere around there. Yeah. So it will not reach the 78 and above kind of data, right? And for zinc column, the part that is also different is the thermal emittance part. Compared to a painted product, it will be different because of the finishing difference, right? So these two parts, yielded to a result of SI in between 60 to 70, not higher than 78. That's for sure.
Okay. So from the floor, is there any question? So you can actually raise to Mr. Rocky and Zaidi.
Abi, Zawa here. I have a question. Actually, for Mr. Zaidi, on the water runoff that you presented just now, I remember there's some other talks that they mentioned. Let's say you would have some recommendation of the minimum roof pitch for your different profiles, right?
Yes, correct.
Then how about like the instances where the roof may be very deep and then there are also it exceeded the sheet length and there would be lapping? Would there be a recommendation of say a slightly different pitch on that for better?
You're looking about different pitch or the lapping part that you worry is now?
The pitch, because I can't remember which out was it. Someone recommended, let's say if there are lapping, then they would recommend a slightly different pitch, a more.
Okay. I think okay. In our industry, when it comes to lapping, I mean when pitch of lapping. So when you have I think if I'm not wrong, 3 degree and below, we will recommend the so-called the lapping lap is something like 300 mm lapping to allow for. So if you want to have a lower lapping, I mean lower pitch, then your lapping area will be longer, maybe like 600 or something like that. This is because to make sure that things don't backflow. But lapping is not an issue at all as long that it's been properly installed and the lap has been allowed for a proper distance. I think it should be okay. That of course the pitch and in our industry that there's the lower the pitch are, the longer your lapping so-called distance. And if it's the higher the pitch, I think your lapping distance will be slightly smaller. That's all. I think you don't have to change I think in terms of design, when you design to select a profile, we are going to calculate the whole piece of line, either it's lap or not lapping. That is where the performance is, not about the lapping issue.
I see. But you will definitely be able to recommend based on different design, right?
Absolutely.
Okay.
I mean, look at the housing industry nowadays. Those days when we use clay tiles, all 17 degrees and above. When the new millennium, some of the architects look at the way the Mediterranean design, they want to have a contemporary design where they want a flat roof. So that's where metal decks coming in to actually able to perform, especially in our tropical country, take care of the rains, that kind of thing.
I think housing is not so critical, but more of an industrial where they have a very large roof span.
Yeah.
And a lot of
I think
and
when come to very large roof, I think the profile I think is very important. When the design we actually calculate for you, I think whether it's 1 degree or 2 degree or 0.5 degree would be able to take care of all the requirements.
Okay, thank you, Mr. Zaidi.
No problem, anytime. Any more questions?
Okay, any more questions from the floor? Okay, if not, actually I got another question. Because talking about sustainable, currently a lot of roofs, especially industry building with big roof covering, is installing with solar panel. So is there any tips for the architect for roof selection which preferable for solar panel installation?
I think solar panel, I mean, in our so-called ready project that people talk about solar panel, I think the solar panel to some extent, I would say, is matured in terms of installation. They have a lot of accessories available to accommodate to many type of profiles. So the only thing that we always said that try not to puncture the roof. This is one of the elements. The tips that once you have somebody to install your solar panel, just make sure they don't puncture your roof. And there are many cases that these people actually, happily puncturing your roof, and they start leaking and blaming the roof again. And the accessories, I think, is widely available. And the other element of installing solar panel, to what I know, that you have to look at the structures, design, whether it can take the new load. But I think the solar panel is not so heavy. Once you have a distributed load, I think most structure were able to take care of the load. But again, we have two type in structures. I think you have a massive type which can take more loads, and sometimes you have a lightweight truss. Probably, if you design at that time lightweight truss, you say, hey, I'm going to have a roof. Then eventually I want to put a solar panel. Probably that the designer will have some a bit more safety factors to take care of the loads, that kind of thing. And I spoke to some of the solar panels. Sometimes they've been blamed. The performance of the solar panels are not as per mentioned. I think people have to understand this. I believe architects also have known that the orientation of your roof must be right. If you are facing north and south, then the sun from east, it doesn't give you the numbers that you want. Of course, the solar panel, I mean, talking about 20 meters square, whatever, it's supposed to perform to certain amount of to produce certain amount of power. But they guess, they complain they didn't get the power. I think they have to understand that. I think you really want to do it. I think make sure that the orientation is right to some extent.
If I may add, because with from BlueScope perspective, we did encounter some random questions regarding the material. So I think the last part where I just presented earlier about the material compatibility, that part. So I will agree with Zaidi in the perspective that the solar panel vendors or contractors are maturing in terms of they know what they should select in terms of components. But what is not so clear, not from the solar panel side, but rather from the investor or building owner side, is that they will always expect that their existing roof, right, which previously was not designed in consideration of adding additional load. So this is where we do see struggles in terms of between the contractors, so-called the EPCC people from the solar panel guys, and then the owners having a misalignment in terms of, okay, can my roof actually be installed with solar panels? So aside from direction wise, right, all the initial cost saving that they put in, like maybe they use really low thickness or base metal thickness roofing sheets. So end up the EPCC people will like, oh no, I will not install or add additional load onto your roofing sheets, because previously roofing sheets was only considered as an architecture, but then there is also called the structural load now, because you need to add additional components on the roof. So this is where we see a lot of owners starting to change their roof, despite maybe last time they maybe 5 or 10 years ago they say, oh yeah, I just want a roof, but then now they want a roof with solar panels, so they have to change it again, right, to make sure that it meets the requirement to add the solar panel. So learning from this lesson, I think if let's say you are designing for new warehouse, I think one of the additional questions you should ask and then preempt them is that should they need to consider in the future, not immediately now, but in the future, they want to add certain component. Right now it's only solar panel, but we don't know what other components that they can add, because it is wasted real estate on the roof. Now we know that it can be taken advantage with solar panel, right? But in the future, there could be more advanced things that that can be used on this real estate. So make sure that they are aware and there's a line where they do not cross in terms of what is the base the type of profile, and also the roof pitch, and also what is the minimum base metal thickness that they should go for. So it should be in the initial discussion now when it comes to roof design. So that would be the 2 cents from me. Yeah.
Any more questions?
Yeah. I hope they answer your question, Akadabi. Yeah, being muted.
Mute.
Okay, sorry. Okay, thanks for your answer. And so is there any question from the floor? I think if not, then I think we may end this session now.
Thank you, Mr. Zaidi. Thank you,
Thank you.
Rocky,
Thank you very much. Thank you
most
for being with
informative
us.